Yesterday we completed a problem related to problems dealing with the steam table. So today we are discussing about another problem which is the same steam tables. Okay, so please write down the problem. Find the internal energy of 1 kilogram of steam. Of 1 kilogram of steam at 20 bar 20 bar when first one it is superheated. When it is superheated on first condition superheated, comma, its temperature is 400 degrees Celsius. 400 degrees Celsius. And second one, it is wet. It is wet. Its dryness being 0.9. I take Cp for steam. Cp for steam equal to 2.3 kilojoule per kilogram Kelvin. So here Cp value is given. Okay. So you want to find the internal energy of 1 kilogram of steam in two conditions. First one is if it is superheated. It is superheated condition. Temperature is 400 degrees Celsius. Second one, it is wet and the dryness fraction will 0.9. The same problem that we had discussed yesterday. The both problem has so many similarities. Okay, so here you also want to find the internal energy in the case of superheated condition, and next one as wet condition, that is saturated condition. So first, write down given data. This mass is given, like mass is 1 kilogram. Mass of steam is given as 1 kilogram. Pressure is given 20 bar. Superheated temperature is given. Superheated temperature Ts superheat T super is given as 400 degrees Celsius equal to 400 per 273 673 Kelvin. Dryness fraction is given. X is given as 0.9. Cp of steam is given as 2.3 kilojoule per kilogram Kelvin. So these are the given data. Okay. So first condition, it is a superheat. Internal energy of 1 kilogram of superheated steam. So what is the internal energy equation for a superheated steam? Last problem we had taken that H is equal to U plus PV. Therefore you want to find here is U internal energy, U equal to H minus PV. It's normal thermodynamic condition. For superheat condition, you want to take U equal to H superheat minus P into V superheat. Right? Last problem we have already did the problem. We have already used this equation in a problem. So don't go to forget the equation of U equal to H superheat minus P V superheat. Okay, so you want to find the value of H superheat and V superheat. So to find the value of H superheat, some data are needed. So in the last question, we had discussed a problem here. The last question we had taken the value of H superheat. H superheat value we had taken that 3051.2 kilojoule per kilogram. We had taken that value from the table, right? You remember? We had taken that value from the table or superheated table. Okay, so we have plotted a point that the condition where 10 bar and temperature is 300 degrees Celsius. Here it is given as temperature is 10 bar, sorry, temperature is 300 degrees Celsius and pressure is 10 bar. How superheated steam. So രണ്ട് സൂപ്പർ condition ആണ്. 10 bar is superheat and 300 is superheat. Question വായിച്ചു നോക്കിയേ. The internal energy per kilogram of superheated steam at a pressure of 10 bar and a temperature of 300 degrees Celsius. Both are conditions for superheated steam. So we can plot a point from the table of H superheat directly because pressure and temperature of superheat is given. We have directly plot a point that is 3051.2 from our table. But this question, initially a condition is given that 1 kilogram is at 20 bar pressure. It is not said it is superheat or saturated. Initially a pressure is given as 20 bar. Then you want to find the value of internal energy if its temperature is 400 degrees Celsius. So ഇവിടെ pressure അത് superheated pressure ആണ് 20 bar എന്ന് വിചാരിക്കരുത്. It is not given that superheated steam pressure is 20 bar. Only superheated temperature is given as 400 Celsius. Not superheated pressure is given as 20 bar. Only temperature of superheated table is 400 Celsius. So you can't take a particular value of H superheat from directly from table here. രണ്ട് superheat ആണെന്ന് പറഞ്ഞാൽ മാത്രമേ you can actually take the superheat value from the table. Here it is not given that pressure is superheated pressure. So only temperature of superheat is given here. Temperature of is 673 Kelvin or 400 Celsius. So if you data മാത്രം വെച്ചിട്ട് you cannot take the value of H superheat from the table. Therefore, there is an equation for H superheat. There is a standard equation for H superheat. Write down and make it in a box. H superheat equal to HF plus HFG plus CPS into T superheat minus TS. H superheat equal to HF plus HFG. HF plus HFG means HG. HF plus HFG means HG. In some condition you can say that HG is used. So confusion varanda. HG is same as HF plus SFG. Then CPS, CP of steam into T superheat minus TS. എന്തുകൊണ്ടാണ് വരുന്നത് വെച്ച് കഴിഞ്ഞാൽ HF plus HFG is HG, that is enthalpy of gas. Okay, HF plus HFG equal to enthalpy of gas. Next term, CPS into T superheat minus TS means CP delta T, right? CP delta T ആണ്. So initially a gas or water as a heat, initially it was a heat. ഒരു ഹീറ്റ് ഉണ്ടാവുമല്ലോ ആദ്യം. ആ ഹീറ്റിന്റെ കൂടെ നമ്മുടെ സാച്ചുറേറ്റഡ് ഹീറ്റും കൂടി കൂടുന്നതാണ് സൂപ്പർ ഹീറ്റ് എന്ന് പറയുന്നത്. ഓക്കെ, അതുകൊണ്ടാണ് എച്ച് സൂപ്പർ ഹീറ്റും കൂടെ രണ്ടും ആഡ് ചെയ്ത് പോകുന്നത്. ആദ്യം അതിനൊരു enthalpy or temperature ഉണ്ടാവുമല്ലോ. Initially it possesses heat. Okay, initially water or steam possesses heat. That heat plus saturated heat will reaches the steam in superheated state. Steam initially saturated state, superheated state. So initially it possesses a temperature or enthalpy plus the enthalpy of the particular gas when it reaches to superheated. Adum kudi plus heat ആണ് superheated enthalpy വരുന്നത്. So that means the adding term. If you are finding the H value for normal condition, a saturated condition, the second term will be not there. Okay, second term will ഉണ്ടാവില്ല. Initial state only the HF plus HFG must be there. We studied that H equal to HF plus HFG. That is the simple term. It is saturated state. If we are taking superheated state, you want to add the initial heat of the water. Okay, that is Cp delta T. If mass is there, mCp delta T. അതാണ് ഈ ടേമും കൂടി വരുന്നത്. റൈറ്റ്? HF plus HFG plus CPS into T superheat minus TS. That is equation for H superheat. Is that clear? Okay. Then you can take some, you need HF value, HFG value, T and TS value. Okay. See, T superheat already known, CPS is known. So you want to find the value of HF, HFG and TS. For that, we have that pressure is given as 20 bar. Pressure is given as 20 bar. Take the pressure table, 20 bar. At 20 bar, take your pressure table. വേണ്ട എന്തൊക്കെ വാല്യൂസ് ആണ് അത് മുഴുവൻ എടുക്കാം. Pressure table at 20 bar. Pressure table at 20 bar. 2.20. Okay. Top of the table. Pressure 20 bar. We have TS value. What is the TS value? At 20 bar, what is the TS value? Take your table. What's value?
212.4.
Loudly.
212.4.
Kedidada?
212.4.
Okay. Right. 212.4. 212.4 degrees Celsius is the TS value. And on the values I want the HF value, HFG value. Okay. Write down. HF equal to HFG equal to. HF value is 908.6 kilojoule per kilogram, right? And HFG value is 1888.6 kilojoule per kilogram. So these are the values we needed. Okay, then substitute the VG. Some more data are needed. VG value is also needed. VG value. Please write down VG value also. Then VG value is also there. Write down the value for VG, that is 0.0995, right? 0.0995 meter cube per kilogram is the VG value. This volume of gas. VG value. Okay. And coming back to equation, substitute the values and find the value of H superheat. Therefore, H superheat equal to 908.6 plus 1888.6 plus 2.3 into CP value is given as 2.3. 3.3 into 400 minus T superheat degree Celsius in degree Celsius. 400 minus 212.4, right? You will get the value directly. Simple ആണ് ചെയ്യാൻ. Just take the pressure value and go to table and write all the values you needed. Write the equation and just substitute the values. Okay, very simple problem is 3228.68 kilojoule per kilogram. That is the H superheated value, right? Then you want to find the V superheat. So for last problem, we had taken a Charles law to find the value of V superheat, right? Take a last problem, new notebook. Here we use this equation, Charles law, to find the value of P superheat. The same method we can adopt here to find the value of P superheat. That is, from Charles law, we know that B by T is constant. Okay, by Charles law, by Charles law, V by T equal to constant. Therefore, Vg by Tg equal to B superheat divided by T superheat. Vg by Tg. Tg means Ts, temperature of gas, temperature of steam, anything, not superheat. Okay, Vg by Ts equal to V superheat by T superheat. So here we want to know the value of V superheat. T superheat is known value, Ts is known value, and here Vg. Then Vg value the Vg value we have written to find the value of V superheat. The whole value is given. So directly find the value of V superheat. V superheat equal to Vg by Ts into T superheat. Vg value is 0.0995 divided by Ts value is 212.4. But you want to take this temperature to Kelvin scale. ഇതുപോലുള്ള ഇക്വേഷനെ കൊടുക്കുമ്പോൾ പി വി കൂട്ട് എൻ ആർ ടി പി വി കൂട്ട് എം ആർ ടി ഓർ ദിസ് ഇക്വേഷൻ ചാൾസ് ലോ ബോയ്സ് ലോ ഒക്കെ കൊടുക്കുമ്പോൾ വി വാണ്ട് ടു ടേക്ക് ദ വാല്യൂ ഇൻ എസ് ഐ യൂണിറ്റ്. ഓക്കെ, സോ പ്ലീസ് ഐ ഡോണ്ട് ദ വാല്യൂ ഇൻ Kelvin scale. 212 plus 273 into T superheat. T superheat is 400 plus 273, 673 Kelvin. You will get the value of P superheat in meter cube per kilogram. നമ്മളിത് ആ വാല്യൂ എല്ലാം എടുത്തതെങ്കിൽ നമുക്ക് ഈ മീറ്റർ ക്യൂബ് അല്ല കിട്ടുക. ഓക്കെ, സോ ടേക്ക് ദ വാല്യൂ ഇൻ എസ് ഐ യൂണിറ്റ്. So 0.095 by 212.4 plus 273, that is total value into 73. You will get the value of V superheat directly 0.1379 meter cube per kilo. ചെയ്തു നോക്കണേ. So therefore internal energy U equal to H superheat minus P into V superheat, that is 3228.68 minus pressure is given as 20 bar, that is 20 into 10 power 5 Pascal into V superheat 0.1379. You want to convert, we had taken the last problem that you want to convert the value in യൂണിറ്റ് എസ് ഐ യൂണിറ്റിലേക്ക് മാറ്റുമ്പോൾ കിലോഗ്രാം മാറ്റണം, അതായത് 10⁻³ വരും അല്ലേ. കഴിഞ്ഞ ദിവസം പറഞ്ഞ തന്നെ മീറ്റർ ക്യൂബ് പെർ കിലോഗ്രാം is there and we are adding meter cube by 10⁻³ in kilogram. When we are taking the 10⁻³ upward, you will get 10⁻³. So to convert the value, you want to take 10⁻³ ഒറ്റ യൂണിറ്റിലാക്കാൻ വേണ്ടിയിട്ടാണ്. Three two two 8.68 minus 20 into 10 power 5 into 0.1379 into 10 power minus 3. The value is
2952.88.
very good, kilojoule per kilogram. 2952.458. Yes, that is the first question. Then second one. Second one, you want to find the internal energy in the normal saturation state. Okay, first one is superheated state, temperature is given as 400 Celsius. Second state is a saturated state, dryness fraction is also given there. So you want to take also consider the dryness fraction in your problem. The same method. Okay, the whole value, you don't want to take another table here. Initially, that pressure is 20 bar itself. Pressure is 20 bar itself. So you have written the whole value for 20 bar here. So and again, you don't want to take the table. You have written all the values already here. Therefore, just write down, you know that H equal to U plus PV equal to U plus V. Therefore, U equal to H minus PV. H minus P. But here we have a dryness fraction also. Therefore, H minus P into X into V. Then X into V എന്ന് വരുമ്പോൾ വി ജി എന്ന് വരും. അതായത് വിനെയാണ് നമ്മൾ എക്സ് ഇൻറ്റു വി ജി എന്ന് എഴുതുന്നത്. ദാറ്റ് ഈസ് സ്പെസിഫിക് വോളിയം വി ഈക്വൽ ടു എക്സ് ഇൻറ്റു വി ജി. ഓക്കെ, ഇത് മറന്നു പോകണ്ട, ബോക്സിലാക്കി വെക്കുക. സ്പെസിഫിക് വോളിയം വി ഈക്വൽ ടു എക്സ് ഇൻറ്റു വി ജി. എക്സ് ഈസ് കോൾഡ് ഡ്രൈനസ് ഫ്രാക്ഷൻ. വി ഈക്വൽ ടു എക്സ് ഇൻറ്റു വി ജി. സോ ഹിയർ പി വി ആണ് നമുക്ക് ശരിക്കും ഉത്തരം. ഇതന്നെയാണ് നമ്മുടെ ശരിയായ ഇക്വേഷൻ. എച്ച് ഈക്വൽ ടു യു മൈനസ് പി വി. സാധാരണ കണ്ടീഷണൽ ഇക്വേഷൻ ആണ് എടുക്കേണ്ടത്. എച്ച് യു ഈക്വൽ ടു എച്ച് മൈനസ് പി വി. So H can be find out. Okay, H can be find by using the equation HF plus X into HFG. Pressure is given. But how can we find the volume? So to find the volume, dryness fraction is given here. That is specific volume V equal to V ആണ്. ഈ V കണ്ടുപിടിക്കാൻ X വന്നിട്ടുള്ളത്. V equal to X into Vg ആണ്. Okay, അതാണ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുന്നത് നമ്മൾ. V equal to X into Vg. Therefore, you can find the value for the Vg is given. We have taken the value from table. X is given. Pressure is given. H want to be find out. H equal to HF plus X into HFG. X equal to HF plus X into HFG. So HF value HF value, yes, HF value is there. 908.6. HSG value is there. X value is also there. So it's a simple problem. HF can be HF is 908.6 plus X is 0.9 into 188.6. 908.6 plus 0.9 into 188.6. Two 608.34 kilojoule per kilogram. Right?
Sir.
Then just substitute the value. That is U equal to, therefore U equal to 2608.34 minus pressure is 20 at 20 into 10 power 5 into X into വോളിയം എടുക്കുമ്പോൾ എപ്പോഴും നമ്മൾ മീറ്റർ ക്യൂബ് പെർ കിലോഗ്രാം ഉത്തരം കിട്ടിയിട്ടുണ്ടാവും അല്ലേ. നമ്മളെ വോളിയം വി ജി എന്ന് പറയുന്നത് മീറ്റർ ക്യൂബ് പെർ കിലോഗ്രാം ആണ്. കിലോഗ്രാം മാറ്റണം നമ്മൾ എപ്പോഴും. വി ജിന്റെ വാല്യൂ വി സൂപ്പർഹീറ്റിന്റെ വാല്യൂ നമ്മൾ കൊടുക്കുമ്പോൾ യു വാണ്ട് ടു ടേക്ക് 0.9 ഇൻറ്റു ദ വാല്യൂ ഈസ് വി ജി വാല്യൂ ഈസ് 0.0995 0.0995 into 10 power minus 3. You will get the internal energy. HF plus HP H minus P into dryness fraction into Vg. That is, the value is 2429, right? 24 2429.24 kilojoule per kilogram. So that is our problem. Is that clear? So please study how to use or how to choose the value from data book. That is the main issue you will uh, that you facing during studying the fourth module or the pure substance. So there will be a problem. There will be some problem related to this fourth module dealing with the gas tables. So if you can, if you are, if you are, if you are very much confident for searching value from data book, you can directly substitute the value and we can, or you can directly complete the fourth module section by studying this problem step of problem. There are so many problems in your textbook related with the gas tables. So I have we have gone through to I think 4 or 5 problems like that. That we had completed a problem related with the finding the Reynolds fraction. Reynolds fraction. Then now internal energy. Right. Two problems. So the two problems we have completed yesterday and today. The method is to find the internal energy value, change in internal energy value. So the first problem dealing with the first one superheated state, and there are two states initially. You want to deal with the two states, that is saturated state and superheated state. രണ്ടിൽ നിങ്ങൾക്ക് എന്തായാലും ചോദ്യങ്ങൾ ഉണ്ടാവും. ഒരു ചോദ്യത്തിന് രണ്ടും വരാം, രണ്ടല്ല മൂന്നും വരാം, സാധാരണ കണക്ഷനും വരാം. അപ്പോൾ ഏത് കണ്ടീഷനാണ് വരുന്നത്, വിച്ച് യു വാണ്ട് ടു ടേക്ക്, വിച്ച് വാല്യൂ ഓർ വിച്ച് ടേബിൾ യു വാണ്ട് ടു ഗോൺ ത്രൂ എന്ന് പറയുന്നത് നമുക്ക് ശരിക്കും മനസ്സിലാക്കി വെക്കണം. ഇഫ് യു വാണ്ട് ടു ഫൈൻഡ് ദ വാല്യൂ ഫോർ ടി സൂപ്പർ ഹീറ്റഡ് സ്റ്റേറ്റ്, you want to go through the superheated table, or if you need to find the value from a saturated state, a saturated table, you want to go through the saturated table. TS value, HF, HFG, VG, ഇത്രയും വാല്യൂസ് ആണ് എപ്പോഴും വേണ്ടി വരിക. SFG, SG, HF, HFG, HG, VF and TS. These are the six readings you need to find out majority problems. Okay. So just go through the textbook and more problems dealing with the gas tables and make a thorough idea that how to take the value or how to deal with the data. Okay, that is the main thing. So we have an hour 2. So the two problems we have completed is dealing with the finding of internal energy. So now we can do, or we can look after a problem dealing with the finding the dryness fraction, x value. രണ്ടിലും എക്സ് വാല്യൂ തന്നിട്ടുണ്ട്, രണ്ട് പ്രോബ്ലത്തിന് എക്സ് വാല്യൂ തന്നിട്ടുണ്ട്. സോ ഹൗ ടു ഫൈൻഡ് ദ വാല്യൂ ഓഫ് എക്സ് വാല്യൂ കണ്ടുപിടിക്കുന്ന പ്രോബ്ലം നമുക്ക് ചെയ്ത് നോക്കാം. റൈറ്റ്. So this is a complex type problem. The problem will be asking for like 7 or 8 marks. Very important problem. So make a look to how to deal with the type of problem dealing with finding the dryness fraction value. So there is a there are 2 or 3 words dealing with dryness fraction. First one is just dryness fraction. Question dryness fraction value തന്നിട്ടുണ്ടാവും, or will be asking or will be given that it is 0.9 dry അങ്ങനെയൊക്കെ തരാം. അതും dryness fraction ആണ്. Then in some case it will give us as qualityയും dryness fraction തന്നെയാണ്. If it is given as to find the value for quality, find the quality of gas എന്ന് പറഞ്ഞാൽ you want to find the value of x itself or the value of dryness fraction itself. So if it is x is given, dryness fraction is given, and 0.9 dry, quality, these all are equal to that particular one, and it's a dryness fraction x. Okay, dryness fraction എന്ന് പറഞ്ഞാൽ തന്നെ അതിന്റെ ക്വാളിറ്റി ആണ്. So here, there is no problem. Two boilers, two boilers, one with a superheater, one with superheater, and other without superheater, and other without superheater. Are delivering equal quantities of steam, equal quantities of steam into common main, into a common main. The pressure in the boilers are the boilers and the pressure in the boilers and mains is 20 bar. The both boilers and the main is have a pressure as 20 bar. The temperature of the temperature of steam from a boiler with a superheater is 350 degrees Celsius. 350. And temperature of me of steam in main is 250 degrees Celsius. Determine the quality of steam supplied by other boiler, superheated boiler. എൻ്റെ ബോയിലറാണത് സൂപ്പർ അല്ലാത്തതിൻ്റെ ക്വാളിറ്റിയാണ് ഉപയോഗിക്കുന്നത്. ടേക്ക് CPS equal to 2.25 kilojoule per kilogram. Okay, this is the problem. So we can discuss this problem and solve it in the fifth hour. It is next hour. Next hour is also dealing with it. So now we can close this session and take attendance for this session.